Hey, it's Mr. Lineski. We are looking at Unit 1, Section 2, talking about segments and segment addition. For a quick example, say we have a pencil that is 7 inches long and your buddy forgets his pencil in class and he's like, hey, can I borrow your pencil? And you're getting annoyed, and so you end up just breaking off a piece. And the piece that you give him is 3 inches long, and if I asked you how long is the pencil that you possess, hopefully you would figure out that you would say, oh, well, it was 7, and then I break off 3 inches, and so I'd be left with 4 inches. That is essentially the basis of segment addition. As always, we have some vocab that is going to go along with this section. So, first, we are going to talk about what is a line segment. A line segment is defined essentially by 2 endpoints. A line is something that goes on and on forever. A line segment is something that starts at a point and stops at a point. So we could say something like segment AB. We denote this as AB, and I want to remind you that when we have something like this, that is a line. So it is really important that you know the difference between when we have the arrows, it's a line. When we don't have the arrows, it is a segment. Betweenness. The word betweenness means that we typically have 3 points that lie on a line. We can always say that one point is between the other two. Huge important part of this is that between does not mean the middle. It doesn't mean that it's directly in the middle. It just means it's somewhere between those points. So if I had point A and C, and I said point B is between that, that means that B could be here, it could be here, it could be anywhere in between here. It doesn't have to be in the middle. So what exactly is segment addition? It's basically just like our pencil. If I have the pencil PQ, pretend that's our big segment, the whole thing, I'll typically call it, the whole. I have point M that is between P and Q, so I can break it up into 2 segments. I can say segment PM, here to here, and I can say segment MQ, here to here. Basically, it just says that PM plus MQ will equal PQ. I often refer to it as, part plus part equals whole. So this part here, PM, plus this part here, MQ, is equal to this whole thing. Alright, so here are some examples. If I have line segment AC, where B is between them, if I told you that AB was 12, so from here to here is 12, and I told you that BC, so here to here, is 7, what is the length of AC? So I'm asking you, what is the whole thing? So this, again, is part plus part equals whole. So we can say 12 plus 7 is equal to 19, and so this whole thing would be 19. The flip side of that is I can maybe ask you to find a part, not necessarily the whole thing. So if I told you the whole thing was 24, this is more so like our, what's going on here? This is more so like the pencil problem. Speaking of pencil problem, I'm having a pencil problem right now. Why isn't this working? Sorry. 24? Sweet. If this thing here is 24, and I told you that BC here is 15, and then I said, what's this section here? AB. Well, this is sort of like X. Solve for AB, and we can say something like X plus 15 is equal to 24. Part plus part equals whole. And so to solve for X, we just subtract 15 from both sides, and we get that X is equal to 9. This problem down here basically gives you a scenario but does not give you a drawing. So you need to make sure you read carefully. So CT equals 16, JT equals 2x plus 1, CJ equals 3x plus 5. J is between C and T. So I recommend that you draw the scenario out. So here's CT, J is somewhere between it, doesn't really matter as long as it's between. So there's J. I know CT is 16, so that's my whole thing. The whole thing is equal to 16. JT, here to here, is 2x plus 1. And then CJ is 3x plus 5. So these are my 2 parts. here and here, so part plus part equals whole. And so we do 3x plus 5 plus part, 2x plus 1 equals the whole thing, which is 16. And now this is just a little algebra problem. Combine like terms. 3x plus 2x is 5x. 5 plus 1 is 6. And then solve for x. So 5x equals 10. Divide both sides by 5. X equals 2. Where I want you to read carefully, though, it says solve for x and find the measure of each segment. So that means if x equals 2, I now have to substitute 2 back into these problems. So 3 times 2 plus 5. 3 times 2 is 6, plus 5 is 11. So this piece here, piece CJ, is 11. 2 times 2 is 4. 4 plus 1 is 5. And if you check, 11 plus 5 does equal 16. Moving on, whoops, those are supposed to be hidden. We're going to look at some vocabulary words. Parallel lines are basically two or more lines that do not intersect and are coplanar. This also works for segments. It's not necessarily always lines. So I gave you an example of a cube, three-dimensional shape. And we're just going to kind of highlight what parallel lines could be. So like this line here and this line would be considered parallel lines. So notice they're on the same plane, this plane right here, the front of the box, and those sides are parallel. Parallel planes are two or more planes that do not intersect. Anytime you hear the word parallel, it means it's not intersecting. So imagine again that this were a box. So the planes that would be parallel could be the top of the box and the bottom of the box. So the top and bottom never intersect. They're parallel from each other. And then the last word here is something called skew lines. Skew lines are lines that do not intersect and are not coplanar. So this is an example of lines that don't intersect that are coplanar. Skew lines are lines that don't intersect and are not coplanar. So let's say that I was looking at this line right here, or this segment. This would be skew to this line. That's one example. There's lots of examples here. So if you imagine that this line went on forever and ever and ever, and so did this line, they would never intersect because they're on. This is on the front of the box, and this is on the back of the box. But they're not on the same plane, and so we can say they're skew. All right, I'm going to do a few of these problems with you, and then these ones down here, these ones are going to be the ones that you need to try on your own, 11, 12, and 13. So I want to remind you that answers are going to vary here. There's lots of different answers we can talk about here. Name a set of parallel segments. Parallel segments, I can say AD is parallel. You can use this symbol to indicate parallel to BC, this and this. Those are parallel segments. Name a plane that is parallel to plane ABC. So where is plane ABC? A is here, B is here, C is here, so they must be referring to the top of the box. So naming a plane that's parallel to that is the bottom. And so remember, to name a plane, it just has to be three non-collinear points. So I will say plane E, H, F. That works for me, E, H, and F. Name a segment that is skew to AB. So let me erase this stuff here. So if I'm looking at segment AB is right here. Something that is skew to that. So remember, that means doesn't intersect and not in the same plane. I will go with CG, because again, those are in totally different planes, but they would never intersect. So we'll say CG. And then the last one, plane CDH and plane CBF. So let's see. DH is this plane here. And then we are looking at plane CBF. CBF is the front of the box. It's this plane here. And it says intersect at this segment. So where does the front of the box and the side of the box meet? they meet right here at this segment CG. Alright, as I had mentioned, these last 3 problems are for you to try on your own. Thank you for watching. I know it, and now you know it too.